Right, so this video is about driving the Nokia 5110 liquid crystal display, and my aim in the first part is just to get to this point, which is that the display has something on it. In this case, all the pixels are turned on, and that can be achieved just with commands. I don't need to send any data to the display to do that. I'm using the Arduino Nano for this, mainly because I like these breakout boards, this red board that it's sat on. It just makes it much easier to hook all the connections up because you have plenty of ground and VCC points. So the code for this is on the screen now, and in fact that's all it is. It's just those instructions. It all fits on the screen at one time. So I won't be scrolling up and down. It's relatively straightforward, and I will go through it line by line, or at least section by section, to explain exactly how to drive the Nokia 5110 display. So this is the display itself, and it consists of the LCD module, which is in this metal can. And that's mounted down onto this circuit board. This is just happens to be red in this case. And there are 8 connection points, and they're marked 1 to 8. And they're duplicated down here. So conceivably you could cascade these displays by linking across from one display to another. Now on the back, and please ignore these wires with hooks on them, that's something I put on. They don't come with it. You've got these very clear legends. So you can see that Pin 1 is RST, which is reset, Pin 2 chip enable, Pin 3 DC, which is data command, data or command, D in data in, clock, VCC, which is 5 volts. Now actually this display isn't meant to take 5 volts, but don't worry, it's absolutely fine. Light, which you have to pull low to turn on the backlights, which are blue in the case of this module, but you can also get white ones, and in fact the white ones are a bit more readable. And finally on pin 8 you've got ground. Now just looking at the eBay listing for one of these things I bought recently, in the data section here, again you've got the list of pins down there and their meanings and the pin numbers. And there's also a load of stuff here which says, power supply 2.7 volts to 3.3, 5 volts is okay, but part of the screen becomes black. Well, that's nonsense, it doesn't. And in the red notes above, it says use a 3.3 volt controller, otherwise the display could be quite vague. Well, that's nonsense as well. This thing works perfectly well on 5 volts, and I'll show you that that's the case. So now it's time to wire this thing up, and I'm going to use these DuPont cables. They're female one end and female the other, female to female. And I'm going to do it in such a way that on pin 1 I have brown, and pin 2 red, and so on up to grey on pin 8, because those are familiar resistor colour codes, so that I can immediately identify which pin is which colour. So there's the ribbon cable wired onto the connection points on the display, and now I'm going to connect it up to the Arduino. Now only the first 5 of these signals, pins 1 to 5 in fact, reset, CE, DC, DIN and clock, need to be connected to Arduino digital pins. The remaining 3, VCC, just goes to 5 volts, light we need to pull low, so that'll be grounded, and ground will be grounded as well. So we'll connect the first 5 cables to digital I/O, the next 3 just to power supply pins. Right, well now I hope you can see what's going on here. What I've done is I've put reset, which is pin 1, which is the brown wire, on Arduino pin 12, chip enable, which is pin 2 on the display, the red wire, Arduino pin 11, and so on, orange to pin 10, yellow pin 9, green pin 8. Now VCC, which is pin 6 on the display, so that's blue, goes to one of the red strips on here, which are all VCC. And finally light and ground both go to ground, and so purple and grey are on the black strips, so they're on ground. So now I've plugged the Arduino into my PC via USB, and I loaded in the bare minimum sketch so it has no code in it, and of course the LCD has nothing on the display. The blue backlights are on. They're not very evenly lit, which is one of the downsides of the backlighting on this display. But now the aim of the piece of code that I'm going to load in, which I showed earlier, is to get something, anything, to appear on the display. And we're going to do it with commands only. So now I'm going to start looking at this code, and the first bit to look at are these definitions up here. Now these don't get compiled into actual machine code, so they don't get run. They're simply associations of a name with a number that the compiler will use further down. So for example, if we take here, I've defined DC as being 10. So here, where I do a digital write to DC, the code will do a digital write to digital pin 10. So they're just swaps, basically. So what I've done is to find all the pin numbers that I connected the various wires to. Remember, RST was pin 1, and I connected it, pin 1 on the display that is, and I connected it to digital pin 12 on the Arduino. CE went to digital pin 11, and so on. So these are definitions. It makes it easier lower down the code so that rather than saying digital write 10, low, I can say digital write DC, so we know it's the data command line. Now I'm going to skip the this LCD write command function just for the moment and go a bit further down. Now, if you know anything about Arduino code, you'll know that the minimum requirement for a sketch is that you have a setup function and a loop function. And you can see there that I've put a whole load of stuff in setup and I've put nothing in loop. And that's because I want to run, well, the setup code runs once, the loop code runs continuously, and I don't need to run anything continuously. I just need to get some commands sent to the display to set it up and to get something up on the screen. Right, so let's take a look at the first few instructions in the setup function. These are all pin mode commands. Now, Arduino pins are set, or they default to inputs when the machine boots up, because if they defaulted to outputs, they could cause problems. I like to think of it that you've got all the world's nuclear weapons connected to one of the Arduino's pins, and if it boots up in the wrong state, then you've got a spot of bother on your hands. So we need to change the definitions of these pins, RST, CE, DC, DIN and clock, which are, if you remember, digital pins 12, 11, 10, 9 and 8, to all be outputs. So those 5 commands are just doing that. Now the next thing is we do a digital write to the RST pin. Remember, that's reset on the display. Firstly low and then high. And what that achieves is a low going or a low to high pulse on the reset pin of the display. And that is important. That resets the display, sets up a load of default conditions within the display. It's an essential part of getting the Nokia 5110 display to work. And now I'll go on to explain the 6 commands that I'm sending further down. Now, before we can hope to understand what those commands mean and what they do, we need to read the datasheet. And I must admit, I'm a bit of a stickler on datasheets. I believe that you have to read them not once, not twice, but several times. Print it out, take it to bed, just read it at every possible opportunity, because these things really have to be understood thoroughly to make any sense of it and to get any use out of this information. So if we scroll through this datasheet, there's a whole host of stuff on timings and so on. That's not particularly important. This is probably the most important table. This is the command table. And this is where the commands, those 6 commands that we're going to send to the display, are all explained. Now, I'm not going to go through it in intimate detail, but we'll take a look at it. So what I found when researching this video was that these 6 commands are the minimum that you can get away with to get the display to come on and just show a whole set of pixels. 21, switch to the extended command set. That then allows you to set the contrast value. That's important so you don't get the vague display that seller was talking about. Set the temperature coefficient. That doesn't seem quite so important. There are only 4 options for that anyway. set the LCD bias mode. Now you need to read the datasheet if you want to fully understand what that is. Then you send a hexadecimal 20 to switch back to the basic command set. And then by sending this command 09, that's the all segments on, or you might call it all pixels on. And that's what gets us to having something on the display. Now let's just take one of those commands as an example. The first one, 21, hex 21. Now this table is very annoying because they've put the DC bit here in the first column, which means that you have to try and ignore it when you're working out your hexadecimal. So function set is 0010, that's 2, 0, and then these 3 bits here. So for 21, it's 0010, that's 2, and then 0001 would be 21. So PD is low, V is low, H is high. If you go down to the table below, PD is low, 0, chip is active, that's good. V is low, 0, horizontal addressing, that's what we need. And then H is high, use the extended instruction set. So you can see that by going through this table, you can decode those instructions, work out what they do, and get a full understanding of what those instructions are. Now, all these 6 instructions use a function called LCD write command, and that's this thing up here. And this is really the cleverest bit of the whole bit of code, because this is what sets the various pins on the display to the right states to get bytes of information sent over. Now take a look at the first one, digital write DC low. The DC pin, if high, you're sending data. If low, you're sending commands. So in this LCD write command function, I set that low. We're sending commands. Then chip enable is taken low. Then you use this very clever Arduino built-in function called shift out. And by specifying the D-in pin, the clock pin, the order, in other words, whether you're sending the data out most significant bit first or least significant bit first, and all the displays I've played with are MSB first. And then command is a local variable within this function, which is the parameter that's sent in, and it's then put into the shift out function. And then you do a digital write chip enable high again to complete the command. And so by calling the LCD write command function 6 times, I'm able to send 6 hexadecimal commands to the display, 21, B8, 04, 14, 20 and 09, which set a load of stuff up. And that last one, 09, LCD all segments on. I'll just go back to the data sheet. And it is, where is it? Yes, down the bottom here. Where it says D and E, 01, all display segments on. Let me just point to that. There. D and E need to be 0 and 1, all display segments on. Now D and E are in one of these commands here, and they're split up, so it's a little bit awkward. But they need to be 01. So this number here is going to be 1001, which, if you know your binary, is hexadecimal 9. And going back to the Arduino sketch, there's our hexadecimal 09. So that's the command that switches all the segments on. So that's the code. I hope I've gone through it in enough detail to explain how it works. Now let's fire it up. So I need to do a get the right board. Arduino Nano with ATmega328, that's correct. Serial port for my units is COM9, so that's fine. Let's do that. Is that working? No, it obviously didn't take any notice of me. Okay, that's compiling now. And then the code should go out. There it is uploading. There it is going to the Arduino Nano. And there's the command which switches all the display pixels on. Let's see if I can get the camera to focus on that. And there you can just about see all 84 by 48 pixels are switched on, lit up if you like. And so in part 2 of this tutorial on the Nokia 5110, we're going to do this. get actual words to appear on the display.